Okay. So this is exercise 12 that we stopped yesterday. Today we're going to look something new. Okay. So we're still in the series chapter. We're still in the series chapter. So what you need to recall back what is geometric series. Geometric series. Okay. So we have done defining the series Sn with the limitation to infinity. So it's a series with the limitation. If we have one number, if the series ends with one number, for example, example 12, you know that your series, if you count from 1 to infinity, you arrive at 1, okay, then this statement applies. So if you have one number, if this limitation n to infinity of the series exists, then you can call this a infinite series. So you can write something like this. If convergent, again, recall back what is convergent, what is divergent. So if converged means you have, it will end at one number. Okay, it will end at one number. For example, recall back example number 12. So if your series, again, series is that series and sequence you have to different. They are two different things. Sequence is individual number. For example, the blue color, A with curly bracket there. So this one is individual number, the blue color. We call it sequence. But if you add number together, for the first point, it means you add first number. The second red dot here is you add first number and second number. Then the third dot, red color, is you add the first number, the second number, and the third number. So, and so on. So you get a series results. So as you can see, the dot is adding. Then you do calculation. If it's converged, then you'll get one number. So it means that the red dot will end at 1. Okay. So if you have a converged data or converged series, you write in this form. Okay. So if you see exam give you this one, means that it will be a converged series. So or you need to write in this form if the question asks you to calculate whether it is converged or non, is it converged or diverged. All right. So if your data is converged, then you write in this form, in this green color, S equal to sum symbol and AI. Bottom one is your lower limit, I equal 1 until infinity. So remember this pattern, this pattern. Another one, we will not introduce, but you learned this one before. We will bring the name geometric today. We look at what happens if you have a geometric series. I'll bring it very fast. Again, don't confuse series and sequence. Already explained using example just now. The blue dot is sequence. The red dot is series. Okay. So again, if you don't understand what is sequence, go to the previous video already in the Moodle. There's a link there. Click and rewatch the video. Okay. So I think you're familiar with this mathematic model. If you learn about geometric series, you will have A, the first one, because my finger cannot go further. Right, the far A, you see A plus AR plus AR square plus AR power 3, AR power 4, and you have a general pattern AR n minus 1 plus 3 dot. Again, the 3 dot in mathematics equation, it means infinity, means you continue to add until infinity. So you can get this equation. Okay, if you add a geometry series in this pattern, straight away you can use this formula. Means you write sum of the geometry series A R n minus 1. It means that this is a geometry series. Okay, so this is a geometry series. So remember, we have shown you a few examples. So today we look at geometry series that you have this one. So again, if you're not sure what is geometric data, what is geometric pattern, you need to go back to your Maths 1. Okay, you have a linear series, you have geometric series, you have other pattern series. So this one is for geometric series where the R or the ratio between the numbers is changing. Okay, you see all this set of data. You see the first one is A, second one is R, the third one is A R square. Now just a short question. You look at the what color equation here. Okay, my question is, Nizam, can you try to answer the first one, the first number A there? What is the R? How you write AR equal to A? The first one, the first number A there. Nizam?
Yeah.
How you write the formula A in terms of AR? Okay. Oh, I rephrase the question. You see the second, the first one is A, right, Nizam? The first one is A. Second number is AR.
Yeah.
The third one is AR2, right? So my question is that you can see that the first one is without R, right?
Yeah.
If we die also want to write AR, what is the AR power what equal to A?
AR power what?
Yeah, AR power what equal to A? If you want to write all the terms inside this formula with AR, all you see is AR, because the one that you see on the screen here, the first one is A, right? The first one is A. But if you want to write the whole equation here with AR term, how you write the first one? AR power what equal to A?
AR power
Or what? AR power what equal to A?
-1? No.
AR minus 1. AR minus 1 equal to A divided by R, right?
Yeah, A over R. Okay,
so how to get what is the product if you multiply with if you exponential 0, what do you get? 1000 exponential 0, what do you get? 1000 power 0, what number do you get?
1000, right?
X power 0, x exponential 0, what do you get?
Power of 0 will be remain the same number.
Yeah lah, if you are given just to solve x power 0, what do you get?
0.
X power 0, x exponential 0, you get 0. Shakil, can you answer that? Answer is 1, huh? Yes. Okay, 1 million power 1, you still get 1.
Yeah.
Okay, yeah. So back to this question, Nizam. If you want to write the far A there in terms of AR, how do you write? AR power what equal to A?
Power of 0, it cannot be.
So if you want to write the far right, the A equal to A, how do you write? AR power 0 equal A. Okay, Nizam, you look at the second term. AR power what? The second term there, the second AR. The R is
R
power
one.
what? Power
Yeah.
1. Okay. So, do you see the difference between the one we learned before this? Do you see the difference? What is the difference between the power n, or the power above the numbers? Previously, we always start with what? We always start with 1, right?
Yeah.
But if you look at geometry, what is the first number the power will start with? Start with 0. Huh? If you have a geometric series, your n start with 0. Huh?
Oh.
So you have to differentiate the difference between when you have one set of number, what do we start with? The previous one, we always start with 1. But when we talk about geometric, we always start with something 0. Why? Because you look at this equation. A, R, n minus 1. When your n is 1, what do you get? A, R, 0, right? The first one. If your n equal 1, the first number you get is A, R, 0. Do you see that, Shakir? Do you see it, Nizam? Do you see it, Eman? Eman, do you understand what we are talking about?
Yes, sir.
Okay, meaning if geometry, the power is R power n minus 1. So you always get, the first one will always get 0. Then the second one will be 1. The second one will be 1. The third one means you replace this one with 3. 3 minus 1, you get 2, and so on. You always have minus 1 there. So this is called geometric series. Again, A cannot be 0 if you are looking at geometric series. The A cannot be 0. Okay. We already defined what is geometric series. We already recall your memories about geometric series. How do we do calculation for this kind of series data? How we group them together? So, if R equal 1, this one, if R equal 1, what happened? Try to guess. Look at this green color equation. Green color equation. What happened if your R is 1? What is the final answer when you increase your n? What is the answer you always get if your R is 1 and you always changing from maybe 1 to infinity? What do you get? You always get a 1, right? Do you agree? Do you agree? If your R is 1 and no matter how you change your n, you will always get 1 in this formula. Okay, I think Shakir, your mic have some noise. Right. Okay. So the answer will be always get 1, and then you count them together. So not 1, but you always get the A. You always get the A, because if your R is 1, no matter how big is your n, you always get back the final number. For example, A, R, n minus 1, if you start with 1 and your R is 1, so 1 power 1 minus 1, you get 1. 1 times A, you get A. Now your R is still 1, but now you change 2. 2 minus 1 means you get 1. R power 1, you still get 1. 1 multiplied by A, you still get A. What happens if you change your n equal 3? Now your R still 1. 1 power 3 minus 1, you get 2. 1 power 2, you still get 1. And the third one, you still get A. And you continue until infinity. Infinity minus 1, you still get infinity, very big number. 1 power infinity, you still get 1. You still get 1. 1 multiplied by A, so you still get A. So how do you add this set of number? Can you write this one in a formula? In a linear formula? This is you add manually one by one. if you want to make it into a multiplication equation, how do you write this one in what? Sn equal to what A? Can you guess? It will be S equal to NA. Do you agree? Because the A is, it depends on how many N that you calculate. So you can write this one to Sn, means the sum of all the numbers in this pattern will be equal to An. Edmund, do you understand this, the yellow color equation?
Yes, sir.
Okay, good. Stop me if you're not able to understand the yellow color equation. If R equal 1, using this geometric series, if R equal 1, you always get A, no matter how you change your N, and you add all the numbers together by using this geometric pattern. You increase your N and you add all the numbers together. You can use a very simple linear equation, S sub n equal to NA or AN. Same, huh? So basically, you can say AN, because if you increase to infinity, basically you are getting infinity number. Now try to think the definition of convergent and divergent. What happens if you get an infinity series? You add all the number, you get infinity. Does it converge or diverge? Nizam, does it converge or diverge? Or converging or diverging?
Diverging.
Diverging, huh? If you cannot get a solid number or one individual number, you will become diverge, huh? For example, infinity. The number keep increasing. So you get a diverged series. So if we want to have our series to be, so this one I already explained, okay? So you already know when you have a finite number means you get one solid number here, then it's convergent. This is just a reminder of the...
If put limitation, then it will converge, right?
Which one? The A.
This one, yeah, NA.
No, I mean the NA, the NA, yes. And then you take the, correct, if you put the limitation, you count from 1 to infinity, you'll get infinity. Because you put a limitation there, means you limit the calculation from somewhere to infinity or somewhere to somewhere. In this case, if you use the infinity limitation, then you'll get infinity. However, if we have a solution to prove that the formula that when you count, you will get one number, then you won't get infinity. Okay, means yeah. Okay, so this one I already explained just now. This slide basically just to test you whether you understand whether if you see infinity, does it converge or diverge? Okay, the answer is diverge. Huh? If you see infinity, no matter it's positive infinity or negative infinity, you get divergence data. The next one. Just now we see one scenario where R equal 1. Now we check this geometric equation again. Now we change the R. What happens if your R is not equal to 1? R is not equal to 1, and the A, this A constant value, A, is not 0. What do you think? Will it be converge or diverge if you use this formula? What do you think? If your R is not 1, it can be more than 1, less than 1, or anything. So let's see. So this is the formula if you want to add all the geometric series together. For example, you add, the first one is A. Why you can get the first one is A? You use this formula. What is the first number in your series? Your n equal 1. So n equal 1. 1 minus 1, you get 0. R power 0, you get 1. 1 multiply by A, that's why you get A. How you get AR? When your N, AR is second number, and your N is 2, so 2 minus 1 R, so that's why AR power 1, you get AR. The third number, AR power 2, how you get AR power 2? You replace your N equal 3, 3 minus 1 equal 2, so AR power 2, that's why you can get this one, and so on. So the last number will always follow the equation. Okay, so let's say we get the first equation, then the second equation. We have 7 more minutes then before I will go for a break. So we modified the first equation. We try to take away the minus 1 in the equation. How we take away the minus 1? Because you know that if you put this one as unknown, R minus 1, what does it mean? It means you divide, right? ARN minus 1 means if you only look at AR minus 1 means you divide with something. So you want to remove the minus 1, or you want to remove all the R, what do? You multiply by R. So equation 1, you multiply by R, the whole equation, you multiply by R, you get the second equation. You get the second equation. So first equation, the whole equation you multiply by R, so the far left, you get R power Sn. And the first one, because you multiply by R, you got A become AR, second one AR become AR square, the third one AR power 2, when you multiply you get AR power 3 and so on. The last number you will get from this one become AR power N, the minus 1 gone. Okay, so this is how you manipulate the equation. Now, then we take 1 minus 2, equation 1 minus equation 2, you can write in this way. Okay, you take equation 1, equation 2, you minus this one, you'll get Sn minus R Sn. And then how you get A minus An? Why? You look at the second, you put AR minus AR, you take away. Okay. Do you see how you get from here to here? Do you see how you get A minus ARN? Because we cancel all the term inside here. Because this one minus this one, you can cancel this one and this one. Same with this one, AR minus the AR, you can take away and so on. You can cancel then, and then the last one only left out the last one and the first one. That's why you only get A minus A power N. Edmund, do you understand? How do you get that? Okay, let me stop the recording. Okay, give me a minute. Hello, Mania? Yeah. So I can go now. Yeah. You give me 3 minutes. Meeting room. Okay. Can. All right, bye. Okay, sorry for the disruption. We will run a bit faster. So you get this equation, Sn minus R Sn equal, okay, let me prove it, equal to A minus AR power N, because we can cancel this one with this one, because we take equation 1 minus equation 2, this one minus this one minus this one, and so on. So you can rewrite your equation become Sn equal to A1 minus Rn divided by 1 minus R.
So how do you get the ARN? The second equation.
This one.
Second equation, yeah. The last one, ARN.
Okay, so you take the whole equation. Imagine you take the whole equation.
R, yeah.
Minus the whole equation. So it means this one minus this one. That's why this positive.
The
Yeah.
second equation, how do you get the last?
You mean this one?
Yeah, AR1.
Because the second equation, how you get second equation? You take the first equation, multiply by r, right?
Yeah.
What mean by -1 in equation?
-1
R
over.
-1 is over, right? Over means a divided by r, right?
Yeah.
So what happen if you multiply r? You multiply a r in this term. You take out the r already, right? You take out the -1 already, right?
Oh, so the -1 become n. Okay.
Yeah, this one become this one.
Okay.
Okay. Okay, so we stop here. Huh? Stop here. Let me stop the recording. We will continue.